Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. I don't know what the title of this lesson is going to be. I'll title it in the video title section. But what I do know are our two goals. And we have two goals. I'm saying that twice. Our first goal is going to be a review of reflections and their properties. And our second goal is going to be creation of rules for reflecting over the x-axis, y-axis, the line y equals x, and the line y equals negative x. We will review how to graph these. Let's jump into our first goal and review reflections. Remember, reflections are flips. They are flips over a line. So here I have a pre-image, and I know that I have a pre-image because nobody has a prime mark. And here's my line of reflection. So what I'm going to do is I'm going to take this triangle and I'm going to flip it over the line to its image. Notice that point A is the furthest point away from the line of reflection, and when I flip it, A prime is the furthest point away from this line of reflection. So reflections respect distance, and so we'll see what I'm talking about here in a second. So what is happening when we reflect over a line? We are drawing points on the other side of the line of reflection that are the same distance from the line of reflection as their pre-image counterparts. So the distance from C prime to the line of reflection will be the same as the distance from the line of reflection to C. The same thing for B prime and B and A prime and A, okay? So the distances are reflected. To ensure that all points of the pre-image and the image are the same distance from the line of reflections, lengths are measured at right angles to the line of reflection. A fancy way to say at right angles to is perpendicular to. We say perpendicular means at a right angle. So I have an example here. I have a triangle, RST. I have a line of reflection. I'm going to take my ruler and make a right angle to the line of reflection and measure how far away the points are. Let me just get to a nice whole number so I can do this hopefully simply. So point R looks to be 2.5 inches away. So let me see if I can do that. No, it looks 3.5 inches away. Okay, so that's going to be R prime. And point S, let me do this again. Point S looks to be a little bit more than 6 inches away. We'll say 6.5. We'll do the same for this. So there's my S prime. And point T appears to be 9 inches away. We will do that for its counterpart of 9.5. All right, and there's T prime. Okay, let me connect the dots, and hopefully it looks like I flipped it over that. It looks a little bit off, but I'm doing this by hand. So let's also do a couple more things here, just to stress this. Again, R is the same distance to the line of reflection as R prime, and so we would expect these lengths to be congruent at a right angle. Same thing for S to the line of reflection as is S prime, so there would be at a right angle, and these two segments are congruent. Same thing with T to the line of reflection, and oh, there's my problem, T prime, that wasn't straight across. These again will be the same distance away, and that's what these marks are showing. Okay, so again, this is drawn by hand, so it's gonna be off a little bit. But again, the important thing is the distances are the same from the line of reflection to the points and their counterparts. All right. So I'm gonna hit pause, clean out the whiteboard, jump into the second goal. It's probably gonna take 2 more segments to complete, so I'll be back. I'm back. All right, let's go ahead and jump into our second goal. And our second goal is going to be the creation of rules for reflecting over the x-axis, y-axis, y equals x, and y equals negative x. So we're going to start off with a reflection over the x-axis. That's an x. So remember, this is the x-axis. And so I'm going to take my shape, I'm going to flip it over the x-axis, And every point in the image will be the same distance from the line of reflection as the point in the pre-image. So let's go ahead and start looking at how far away each point in the pre-image is, and then we can copy that length below the x-axis, because remember, this is the line of reflection, so let's add that in here. The line of reflection. Okay, so let's start off with point A. Now, A is actually 5 away from the x-axis, right? So it's 1, 2, 3, 4, 5, 5 away. So if I'm going to reflect it, it still needs to be 5 away, but on the lower side of the x-axis. So it actually maps to here. This would be where A prime is. Right? It's 5 below. But now it's 2, -5. B has a height of 1 off of the x-axis, so when we reflect it or flip it over the x-axis, it's still going to be 1 away from the x-axis, but it's now going to be 1 below the x-axis. So B prime is 4, -1, and C is 2 above the x-axis, so when I reflect it over the x-axis, it should be 2 below. Right here, so C prime is 1, -2. Let's connect these dots here. And that is the reflection of this triangle over the x-axis. And so I'd like to list the points here to try to create the rule. List the mapping. Sorry. So A, let me see if I have a better marker here. A, which was 2, 5, mapped to A prime, which was 2, -5. B, which was 4, 1, mapped to B prime, which was 4, -1. C, which was 1, 2, mapped to C prime, which was 1, -2. So the order, the numbers are in the same order, but what looks like is happening is the y value is changing signs, right? So to reflect over the x-axis or flip over the x-axis, it looks like the y value changes sign. So the rule, write it down here, the rule for reflecting over the x-axis is xy maps to x, -y. Remember, if I put a negative, that's how I show the sign is changing. Let me make the y's the same. I don't know why I write my y's differently every time I write them. So there we go. All right, so that's the reflection over the x-axis. Let's move on to the reflection over the y-axis. All right, let me draw a line here so we got space, and that shows me that marker is no good. I'm running out of markers here. All right, so we're going to now flip over the y-axis. So this is my line of reflection. And so we're now looking at horizontal distance instead of vertical distance. And let me see if this marker is any better. I'm really running out of markers here. All right, so point A is 2 away from the y-axis. So it maps to A prime, which also must be 2 away. Oh, that was a good marker, all right. So A prime is going to be -2, 5, okay. B is 4 away from the y-axis. So its image or its counterpart must also be 4 away on the other side. So B maps to B prime, which is -4, 1. And C is 1 away from the y-axis. So its counterpart must also be 1 away. So C prime is -1, 2. Let's connect these dots. And again, we flipped over the y-axis, which was our line of reflection. Again, let's list the mapping and see if we can find a pattern here. I guess I can do it right here. And I want to make sure I'm still on this whiteboard. I would hate to do this whole lesson and not be on it. Okay, I think I'm okay. Yeah, I'm okay. All right. So A, which was 2, 5, maps to A prime, which is -2, 5. And B, which is 4, 1, maps to B prime, which is -4, 1. And C, which is 1, 2, maps to C prime, which is -1, 2. So looks like the rule for reflecting over the y-axis is, again, the numbers stay in the same position, but now we're changing the signs of the x. So the rule for reflecting over the y-axis, right, your y's like that, is xy maps to -x, y. So the signs of the x are changing for this. So let me go ahead and erase everything. We'll come back and look at a scenario for mapping over the line y equals x and the line y equals -x. So let me clean this up and I'll be back. I'm back again for the last time, I promise. So we're working on the second goal. We're going to create rules for reflecting over the line y equals x and y equals -x. I have my triangle set up on the graph, and I have my equation y equals x. Let me remind you how to graph the line y equals x. There's some hidden numbers here. Y equals x becomes y equals 1 over 1x plus 0. That's my slope, that's my y-intercept. So I begin at 0 on the y-axis, and I move to the next point by rising 1 and running 1 to the right, and connect these dots, and I've graphed my line y equals x. Where's my, right there. Okay, so I begin at 0. I rise up 1, I run 1, and there's my second point. And this is going to be my line of reflection. Right here. Oh, very good, there we go. So this is my line of reflection. It's now diagonal. Okay, so let me write that down, that this is the line of reflection. All right, and so what I'm going to do is I'm going to use the method that I did at the beginning, where I just flipped it over and I used the same distance on the other side of the line here. If we were in class, we would be doing this exercise with patty paper, and what we would do is we would draw this on a piece of patty paper, and then we would flip it over and trace it, and we would see how it worked out. But we're going to have to use this method in this environment. So I make a right angle to my line of reflection, and I figure out how far away that point is, and it looks to be about, let's see, 10 away, right? Oh, I go, wait, let me do that better. That's a right angle, there we go, okay. So it's 10 away, which takes me to here, okay. So that's gonna be my C prime right here. Where am I going to write that? C prime, and that's 2, -1. Let's see here. How far away is this guy? It looks to be, I'm going to learn do math, 17 away, so that would take me to, let me make that a little bit better. Okay, it would take me to about here. All right, that would be my B prime. And I'm sorry that I'm blocking this. And that looks like that's at 1, negative 4. And let's measure the A prime at a right angle. Let's put that at 50. Okay. And that looks like I'm 23 away. So 23 away takes me to about here. Okay. Oh, let me do that again. 23 away takes me to here. All right. There we go. And that's my A prime. And that's at 5, comma, negative 2. That's not, it's supposed to be at 5, comma, negative 2. All right. All right, so let's connect these dots and let's see what the triangle looks like. Here. Oh, it is negative 2. That's close enough. All right. So you can see that the triangle flipped over the diagonal line, and I had to use distance for this one. Let's figure out the mapping here, and hopefully we can create a pattern for reflecting over the line y equals x, or create a rule. And where did I have that good marker? All right, so we'll do the mapping. And A, which was minus 2, 5, maps to A prime, which is 5, negative 2. B, which was negative 4, 1, maps to B prime, which is 1, negative 4. And C, which was negative 1, 2, mapped to C prime, which was 2, comma, negative 1. Now, this is drawn by hand. It's going to be off a little bit. If I had a perfect grid, it would be much more on point, on spot. But again, because we're distance learning, I figured that this would be the best way to show this by using the perpendicular length to each point. So it looks like I'm taking my numbers and I'm just switching them. So the rule for reflecting over y equals x is going to be the following. xy maps to y. We're just switching the coordinates. X goes to the y position, y goes to the x position. So let's go ahead and look at our second graph, reflection over the line y equals negative x. Again, I'm going to go through the steps to show you the equation on how to graph this. I'll use distance to map to my image, and then we'll hopefully, again, find a rule based on this. And again, it's going to be off a little bit. I had to draw it by hand, but I'm hoping that the ideas do translate. All right, so like before, there's hidden numbers, and this equation actually becomes y equals minus 1 over 1 x plus 0. I begin at 0 on the y-axis, and I move down 1 because I'm rising in the negative direction, and I go right 1. So I begin at 0, 0. I go down 1, right 1. Let me connect these dots. And I've been blocking the board a bunch on this one. I apologize for this lesson. A little harder to teach this without having you guys here working on it with me. All right, there's my line of reflection. Let's make sure we note that. This is the line of reflection. Let me move this so I don't trip over it. All right. And so again, like before, we're just going to find perpendicular distance to each point, and then that'll be, we'll use that to graph the point on the other side. Notice here, I just basically folded over on this line, right? So we're going to have something very similar to that with this. So let's just find these links. All right, you are 10 away, and 10 away would get me to here. Okay, there's C prime. Well, it's a little bit. This is where C prime is supposed to be. So C prime would be -2, -1. Okay. B, which looks like it's 17 away. 17 away. Let me get that a little bit more right angle. There's B prime, which becomes -1, -4. And let's look at A prime. How far away is it? 22. Is that right? No, 22. Yeah, 22, okay. So this is where my graph is off. I'm going to fudge this one a little bit. It's supposed to be at -5, -2. Because again, remember, this is handwritten. A prime is -5, -2. And if we connect the dots, we see that the triangle did in fact flip over. And it's off a little bit because it's hand drawn. I do apologize. But the result is going to work. Okay. All right, so let's look at the mapping here. I'll erase this out of space. The mapping. A, which was 2, 5, mapped to A prime, which was -5, -2. B, which was 4, 1, mapped to B prime, which was -1, -4, and C, which was 1, 2, mapped to C prime, which was -2, -1. All right, so what it looks like to me, what's happening is the order is changing, and not only is the order changing, but the signs are changing. So the rule for reflecting over y equals -x is going to be xy maps to -y -x. Remember, I'm switching the order and I'm changing the signs. All right. So hopefully this made sense. I know that, again, the drawings are off a little bit. It's drawn by hand. If we were in class, I'd be able to project a picture and draw a more accurate representation. But if I project, then we just see a giant light reflection and it doesn't work well for us. So hopefully we do see that how this is flipping. What's most important is the rules that we created. These are the rules that you're going to need to answer the questions in your homework assignment. So make sure you have those handy for you. Again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.